Audio test, audio test, audio test. Hi guys, welcome back to the stream. So since we last left off, I promised you that I would get a working emulator, get Box back working, so we can debug. I have done that, kind of. So what I have done is reverted back to the master branch to bring us back to multi-boot 1. So that will allow us to have floppy drive support, since we can't fit Grub 2 on a floppy drive, and Box can really only support a floppy drive well. Now, with that, there was a bug in master dealing with the multi-boot header, and all I've done is added a separate multi-boot section that contains the header and put that at the beginning of the text section. As you can see here, this is the linker script that puts together the kernel, sets up memory addresses and all the sections and all that. So today, hopefully, we'll have the ability to load a driver bundle. So the idea is going to be that there is no drivers compiled directly into the kernel. It is all compiled in is all loaded in at boot time to keep the kernel small and create a little more flexibility. Now, to do that, we need to be able to load a driver bundle, which we'll be talking about that file format as we get to it, but essentially it's a whole bunch of elf stuck together that'll act as the drivers. So what we're going to need to do is get Grub to load files, which multi-boot calls modules, boot modules, and I've got the Grub manual and multi-boot spec ready to go for that. From there, we're going to have to get the kernel to load that, save that memory address, and then parse out that file. Real quick, this is how the OS boots up. It is working fully. I'm going to shut that down. Git add commit push. I had to make a small change to the box RC. Let me get that pushed. And we'll switch over to what is it? Git switch. Let me see. Do we have a branch loaded up for this? No. So, let's make a branch. Dash branch, and we'll call this driver bundle. Okay. So, push that. And as soon as it comes over, we got driver bundle. Good. So, first thing is going to be, let's look at how our driver bundle will come across. So, in the multi-boot spec, we need to check if we've got a flag. Flags, OS, indicate requirements, doesn't under the, can't fill it. To load. 16 through 31 are optional. Okay. Bit 0. Then all boot modules must be aligned on 4K on page boundaries. Yes, we are going to want that. So, we're going to need bit 1, or bit 0. Then the available via at least mem star fields must be included. Do we use that? How do we build our mem map? I think that's in mem.c, yes. Multi-boot info, MBT, multi-boot memory map. We do use that. I think we actually have that flag set. Information about video mode. Don't care about video mode at least yet. Then the fields at offsets 12 are valid and the boot. I don't think we need bit 16. Okay, in that case, we need to go up here. We get the module line. So we already set the 2 bits that we need. Good. So as you can see up here, we align all the modules to page bound with bit 0 here, and we get mem info there, which obviously since we use it. There's our flags, check the magic field, and our checksum, and then again all that gets dumped down here. So, in that case, we should now be able to write in some code here to GDT, where do we build the mem map? PCI. Well, this is gonna go away. So I'm gonna just comment out this whole block, because we don't actually we won't be using that anymore. So what we want to do is write a function, and is it going to be, first big decision we're going to need to make is it going to be a class? And I'm inclined to say no. We'll end up with, so we'll say read boot mods, and again we'll pass it the MBD. We'll pass the MBD, which is the multi-boot data, or the multi-boot info T. So in here, I'm gonna go in drivers, and we're gonna make a new folder, which is boot driver bundle. Actually, that doesn't follow my naming scheme. Driver bundle. And it still doesn't follow my naming standards, even though half the time I don't follow them. And new file will have a load bundle .h and new file called load bundle.cpp. This found if not def. We'll do drivers, driver bundle, load bundle, h, pound define that, and if pound include global.h. That makes it a little bit easier, and this should pound include load bundle.h. That should be quoted. And we're going to need to include that over here too. Drivers / driver bundle load bundle.h, and I should have a configuration, at least I thought I did. Okay, I guess I don't have a configuration for this. Doesn't really matter. So, we're definitely going to have... Alright, now I'm just going to return a void until I decide how I want this to return, and it's going to be load bundle. Yes. No, read boot mods. And terminal right, terminal. If I could just learn how to type, right string, and this is going to be loading driver bundle. And we'll grab that done, because I don't really feel like typing. Okay, so this gets a multi-boot info t, which gets included from multi-boot. Spec multiboot.h. Now, getting to the text segment, don't care about that. Machine state. Okay, boot information format. So flags, upper, lower, boot device. Might want to look at that. So there's going to be some things that we need to add here. The question is, why do we get the M map without setting it? Who knows? I don't really care. I do need to set flag 3, which is going to be modules is an equation which is 1 bit shift bit number 3, and eventually we'll look into getting the command line, which is bit number 2, and we'll look at some of the mem map, making sure that we get that through bit 6 on the flags, possibly boot device, which we already get. Maybe. Okay, let's see. Texture, The multi-boot information structure related substructures may be placed anywhere in memory, except memory reserved for kernel and boot module, obviously. To avoid overwriting this memory until it's done using it. Now, given that we don't overwrite memory yet, yeah, we shouldn't be overwriting memory until we actually read it. Yeah. There's boot device, bootloader loaded the OS from, If bit 1. This should say, this should be load modules. Maybe. If it doesn't work, we'll go fuck around with that number. And address the module itself. Okay, so first thing we're going to do is say assert, which I'm 99.9% sure I've defined already. And it's going to say that the MBT, oh, I should not be writing this in the header. We should be taking this and saying void read mods, read boot mods, with a multi-boot info t called the MBI, and say MBI dot mods count, and say auto count equals that. Speaking of which, unsigned long. Cool. Yes, because that would be 4. So really we want a uint32t. If I was reading that right. Yes. Mods count assert. We won't worry about asserting that. So we'll say if I want to check something. Okay, good. It is readable. I was just looking over. It looked like it wasn't readable. Fuck off, LastPass. Don't remember my password, which isn't even my password. Okay. If count is greater than 0, then we can continue. Else, abort. And I should probably print something. Printf. No bundle loaded. Can't boot. Bailing out. And we need to pound include utils. No, utils slash printf. Cool. Let's make sure we're making progress in this still build. Could not. Oh, that should be a pointer. Oh, yep. Man, it would really help if I remembered how to program. Okay, we look good. Let's see here. Now, for each one, we want to take and say the for int I equals 0 unsigned int. Int I is less than count I plus plus. And with that, we want to take and say the module info. Okay. Contains a physical address count, which may be 0. String provided. Okay, so we need to go check what that thing is called in multi-boot. We've got a module. Yes, that's exactly what we want. So we take and say module mod equals, where's the lowercase m? Yeah. Good, that does reference the right thing. Equals contains the physical address of the first structure contains the physical address of the first structure. So that's actually mod module pointer. Mod equals MBI mod address, and actually we don't want to do that yet. Then we want to do this, do that, and say so the driver bundle, the custom file format that I'm building, and the first field in it is unsurprisingly a magic number. And that magic number is going to be E0DB, or XOS driver bundle. 16-bit number, so we want to say if, so we're going to say uint16t mod struct, and we'll say mod equals, got a uint16 pointer, mod equals mod struct get the start, mod start. And let's make sure we've got everything right. Invert, yes, I know about that. That's fine. Okay, so this gets cast to a module pointer, and this gets cast to a uint16t pointer. With any luck, actually I'm gonna parent that. Make sure it casts the right thing. And with any luck, this will actually build properly. I'm most worried about that one because that's a complex type. And apparently it had no problem with it. So that's good. So now we say if mod dereference, if dereference mod equals 0x e0db, then we're going to do something. Else we're going to printf unknown module. No, stop it. Shit. What's redoing this damn thing? Control Y. Okay. Dual found. That should have a \n after it. And what does abort do? Right. It kernel panics, which is exactly what abort should do. Okay. So hopefully when we build this, we'll be happy. Again, semicolons are a problem. Now, if the mod is correct, we will read driver bundle with mod. Which will be a So how we're going to read this, okay, so we probably will create a struct for this, which will be nice. So let's go ahead and, I don't need multi-boot info anymore. Just check what else I had flagged here. Oh, yeah. And yeah. Yep. Alright, we're done with the multi-boot info, or the multi-boot spec for right now. So, read driver bundle. We're going to go here and we're going to say void read driver bundle. And it's going to get a uint16t pointer called mod, which will rapidly get changed into something different. This comes here, and what we first need to do is probably define this struct, which will go in the header. Up here. Struct called driver bundle. Driver bundle consists of, and this gets the packed attribute. If only I remembered what the actual attribute looked like. Looks like that. So this is going to be kind of interesting because the format is a header, a bunch of driver blocks, and then a footer. Now I may not do the footer just for ease sake, but who knows. Footer may make it a little bit easier for me to determine the end. Oh shit. I forgot double equals that. Okay. So, what we're looking at is having a header. So I think what we'll do is we'll say a driver bundle header. So we'll have a driver bundle header called head, and a driver bundle driver called driver lock. And up here we'll define another struct called driver bundle header, which contains the magic number and 16t called magic, and a uint 32t called something. Oh yeah, count. And then we'll have a struct called driver bundle driver. I may rename that to something different, like body, but for right now that's good enough. Which contains a driver bundle driver config, and it will contain an elf, which for right now will just be uint 16t. I need to get the elf spec. File format. Okay, so there's a 60-page document or the Wikipedia article. I like the Wikipedia article. Offset it to 0, which size in bit is 4. 07F. Okay, so it's a uint 32t called the elf magic. So with the elf magic, we've got that, and we'll worry about reading the elf bundle later. Right now I'm probably just going to stick a random executable that I have in there, because I really don't feel like reading elves and making an elf fully. Life's too short for that. We'll do that later. Let's see. Yes, that should be the proper format. I just need to load the config. So our config, these names are getting more and more verbose. Need another packed attribute. Everything's packed because it's hard to, well, one could predict the size, but I don't wanna. So in here we've got a uint 16t called size. We've got a config. We've got a uint. Did I say 16? It should, both of these should be 32. Called. Actually, we're going to call that the elf size. This will be the config size. No, we're just going to call that the size. And then we've got a char. How am I going to do this? That's how we're going to do it. We're going to call it char, and we're going to say this is the string start. So really what there is there's two strings back to back, one called provides, one calls requires. So a driver will provide one thing and will require any number of things. Both of them are just standard C strings. Basic things. Basic things. You can still read everything, which is nice. So, now that we've got all of this, what we've got to do is first take our uint 16t, well, we've got to call it, we've got to have a driver bundle pointer called bundle, which equals the driver bundle pointer cast of mod. Why do that here? Because I feel like it. I probably could do that cast up here and change that. You know what, I am going to do that. That's going to be a driver bundle. Driver bundle, driver bundle. Driver bundle, and that means we don't have to do this anymore. I have to make sure we're doing everything right here. Right. Dot. Get the mod. Get the header. Dot. Magic. So now that we've got the magic number checked, and we can read the bundle, which we're going to do for int I equals 0, I is less than mod dot get head dot count I plus plus. So we're going to take, and each one of those, we're going to take and get mod driver block, take that, and get the address of that, and get the block I, or call that the driver. That should be a driver bundle driver pointer. Actually, don't really need. Really, we can take that whole thing and make it not a pointer anymore. And fingers crossed that this works. The fuck? No match for that operator. Oh, because that should fix that. Welcome, Ascari, welcome. No match. Oh, right, because I'm using the array index operator, it dereferences it for me. So I can get rid of a set of parens. And we should be, finally, GCC should be happy with me. And it is driver set comparison between signed and unsigned. Fine. Unsigned. Okay, so now that we've got the driver, we need to read its total size and say auto size equals driver dot config dot size and say auto config size equals driver dot config dot config size. Then we get a char pointer. Well, now what we're gonna do is get auto and say something like provides length equals something. It equals Sterling. I do have Sterling in here somewhere, right? I think it's actually in my terminal. Where in the fuck is that? Oh, in my string util. Yes, I do have Sterling. Include utils slash string Sterling. So we get the Sterling of driver dot config dot string dot, what the fuck did I call that? String start. Which should give me the length of what it provides. So then we can say You know, this is all going to blow up because I haven't paged this in. Hopefully somebody remembers that, including me. Need to do that. It's going to be really confusing when I go try and run this and the whole thing blows up with a page fault. Honestly, I'd probably find it, but I'd be very upset. Okay, so now what we need to do is take and say new, we'll say a char pointer provides equals malloc of size provides length. And that should count the, yeah. Now we should be able to say auto requires do I have stir copy? I have split stir comp, but I don't have stir copy. That's fine. I have memcopy, which is basically the same thing. So we're going to say memcopy to char point to provides from, and for the address of driver.config.string start length is provides length. Probably should know if that includes the null or not. While it's not null length. So if it's null, I need to add one to that. For the null. And then requires equals this address of get index provides length, which would be the first character, which then we say, and then we get the strlen of that mess. And I don't know why it's trapping like this, but whatever. How the hell did I turn on word wrap? Thank you. So now, what we need to do is say auto require char pointer requires equals malloc, and I need to add 1 to this for the null. Requires length. Then we do the same memcopy to requires from and throw another ampersand down there for good luck. And I don't need that I need that paren. I need that paren, and I do need this paren. I need a comma and a paren, and this is going to be requires length plus 1. So now we've got all the driver information. I'm kind of feeling like I should have a class that stores all this, right? Build an array of these bundles, or of these bundled drivers. Right, so if I have an array, something like an array of drivers with a name, that, and a pointer to the elf. It's probably going to make the most sense. So, let's do that. Yeah, we're looking good there. Okay. So, if we took and made in here a new file called driver.h, and subsequently a new file called, you know what, first of all I'm going to delete that, and commit the code that we have. Basic mod driver load and read. That should be up on GitHub right now. Less than a minute ago. Yep, 1 commit ahead. And would you look at that? We've got driver bundle, load bundle, and I spelt that one wrong. At least it's a CPP. Okay. There we go, and what we're going to do is a new file called driver.h and driver.cpp. Get you over here, get you over here, get rid of you. And I will be right back. I need a drink of water. Alright, I'm back. Hopefully I can figure out how to use obs a little bit better eventually. Now, as we were talking about, we need a class over here. So, if not def, let's see, drivers, driver, bundle, driver, h, and if. Okay. As we're talking about, we're going to have a class called driver here. Hopefully this doesn't collide with any names. And just going to have a private name. Woo. Let's go take a look at what it's bitching about. Invalid conversion from char to char pointer. I did forget an ampersand there. That's $. That's an ampersand. And I did miss one there. Initialing argument from void pointer to char pointer. Cast to a char pointer. There and there. Expected a semicolon before auto. On 32. Oh, right there. Yeah, yeah. Alright. Whoa. Oh. That was not the right place to put it. That goes here, and we'll wrap that whole thing in another set of parens. I really wish this would stop word wrapping. Cannot convert. What the fuck? Cannot convert a UN32T pointer. Oh, because it should be that. Cool. I did not know about that. I'll have to check out Pragma once. That's an interesting way of doing it. And to use which. Yeah, save me 2 lines. It's so It looks like it has some drawbacks in my quick search. I will definitely look more into it though. Let's see. Go back to you. Okay. We're building this. So we've got a char pointer provides a char pointer requires a driver pointer requires the a void pointer alf, a uint 32t size, that should be all that I need. So then we're going to have a public thing called public constructor that takes a provides a char pointer provides a char pointer requires and a void pointer alf and a uint 32 uint 32t called size. These don't need their underscores. And then what we're going to have to do is make a function called something. Oh yeah. Fill requires. So essentially what we're going to try and build is a graph. And this is actually going to take a driver pointer and called drivers. And a uint 32t size. Now this requires is going to be a comma separated array without any spaces because that just makes life easier. So here pound include driver.h, and this needs to include global.h. So we're going to have a driver. I really don't feel like typing out all those args again. So we're going to say underscore provides equals underscore provides requires equals underscore require underscore size equals size and underscore elf equals elf. Those are backwards. So then we also need get char pointer get provides return provides char pointer get requires char pointer get not char pointer driver pointer get requires array. We also need a requires count. Get requires array requires d. Oops. And we need a uint 32 t require get requires count Thank you, Ascari. I am the worst about remembering semicolons. Return requires and there we go again, and uint 32, nah, yeah, sure. Get size return size. I don't know how useful size is actually going to be, but you know, I feel obligated. Void pointer get elf and return elf. Now that the boilerplate's done, we can go back over here and say something like something. Right. This is going to return a driver it's going to return a how do I want to do this? I want to call it a driver. We'll just call it a driver R, which is going to be another struct driver R, which has a size t count and a driver driver pointer called drivers. And this is going to be driver R. And driver R to ret equal to ret dot drivers sometimes I use uint32, sometimes I use size t. Half the time I don't know what I'm doing, so why not mix things up a bit? That's my theory. Equals new malloc a head deck mod head dot count times size of driver cast to a driver pointer. I really wish this thing would learn to turn things blue when they're type names, or green, or whatever color they turn type names. I think it has to do with not being able to find them. But at this point I don't care. I'll probably fix that before the next stream. Alright, so toRet dot not count drivers index I equals new equals a driver with what order did I put these in? Provides requires elf size. So there we go. Provides requires mod driver block. Actually, driver elf magic. And really it's that dereferenced and cast to, or not dereferenced, address of cast to a void pointer size. That should let me build. Fingers crossed. Oh Lord. Let's try. I expected semicolon at end of member declaration. Semicolon there, semi. Okay. expected primary expression before return. The fuck? There's where I forgot the semicolon. And parens. That explains why it didn't work. Requires D was not. Spelling. It's a struggle. Driver does not name a type right. Pound include driver.h. Yeah, maybe once I fix that, it'll blow up less. Old declaration here. Oh. I forgot to. And driver isn't a pointer, is it? No. Now kernel .cpp does call this. Anybody want to see if it runs? Because I know I do. Don't care. Excuse me while I hopefully don't wreck my layout. And there it goes. Every time. Moving windows is hard. Moving floating windows is hard. Alright. We're loading, we're loading, we're loading. Load it. Huh. Interesting. Interesting. We're getting a 13. 10, 11, 12, 13. Something tells me it has to do with not paging shit in. So let's page. Let's get back out the manual. Does this have a size? Right, I can't read in the size until I page it in. And it doesn't have a size. Well, hold on now. Because we do have a mods count and a mod address. In which case, that doesn't help us. Yes, it does. Yes, it does. Because we can say something like kernel.h and we can say page table.page now if only I remembered the arguments that took. Physical start, virtual start, size. So physical start will be mod addr. Virtual address will be page frame allocator dot, really wish my IntelliSense worked better, get next vert address size in pages. Oh, I need a helper function for that. I really need a freaking helper function. But I'm going to assume one. And my page table, is that size in pages or from bytes? So that should be mods count times size of module. So now we should be able to read mod struct. Now I've got a page in. Mod and we're just going to say 4K. And hope it stops blowing up. Oops. First of all, I forgot to build it. Second of all, I used the wrong variable. Expected primary expression frame alloc is what it should be. And it shouldn't be mod r, it should be that. Yeah, I'm sure Notepad has no God damn it. Use of incomplete type. Oh. Include memory slash structures slash page table.h. Okay. Pound. Yeah, oops. Memory alloc page frame allocator. Oh, right. What does it expect? Size to allocate and base address. Where there? Table dot get kernel start. Okay. After this, should compile. And I just want to make sure that everything's clean, so might as well do it again. Yeah. Other than about 4,000 warnings, we should be good. Okay. Continue you. Okay, that's great. So let's go ahead and see what we're actually doing when we get to that interrupt. Which breakpoints do I have? Right. Yeah, I don't want to do halt, halt. I want to print the breakpoint, and then what is box magic breakpoint? Yeah. Magic breakpoint. Exchange that. I think it's supposed to be double %. Missed the semicolon. Bad register name, okay, I guess it is just a single %. Okay. So we do page fault there. That is good to know. I want to view the page table. Okay, so let's throw in some more breakpoints. Breakpoint. Let's try paging. Brace quit. Okay. I'm bring this over. So here's the debugger. So we hit a breakpoint. Excuse me? Let's hit a breakpoint here. And breakpoint there. And build. And I need to make sure that we don't reset after triple fault. Let's check the box I see. Reset on triple fault equals 0. Magic breakpoint. Yes, it should be 0. I know you don't like my breakpoint macro, but I am sorry, you're going to have to deal with it. And really, what's wrong with it? Okay, so we hit a breakpoint going into loading the driver bundle. And then we interrupt. So So is it getting count? Did I... How? Yeah, I know I'm supposed to do that. Oh, yeah. I know what I'm supposed to do. But currently I don't really care. Yeah, so we recompiled that. Let's go box. Oh, that, yeah. Okay, so we hit a breakpoint. So we can continue, hit a breakpoint, try and read that. Okay. Okay. So you can go die. So right there, MBI is not paged in. Interesting. Problem is, it... Oh, that's why. Duh. Let's just go MBI equals MBI as a UNT pointer. Actually, you know what? Let's just do what I do in here. Retrokernel start. Now that should keep everything from blowing up. Because Grob doesn't realize that. Oh, what the fuck? Oh. Oh, piss off. MBI. MBI. I need to be more careful before I compile this shit. Okay, so we hit a breakpoint, hit a breakpoint, hit a... Okay. Good. Good, that's what we wanted. Mostly. So now we can get rid of all our breakpoint code, all of our breakpoints, and we need to mount our drive, and really all I'm doing now is hopefully adding a module keyword /mnt/boot menu. Let's go desktop 5. So here's my wonderful configuration for Grub. Now looking at the manual, which was ungodly long. Didn't realize it was so goddamn long. To load this properly, we need to give it the module command. Okay. File, okay, no interpretation of the file is made, so the user of this command must know what to do. Okay. The rest of the line is passed in as the module command line. Okay. You must load a multi-boot kernel image before loading any module. Okay, I don't care about automatic decompression. So, in that case, we will say something along the lines of /boot/driver dot EODB. Yes. Now I need a hex editor. XXD. No, that's not what I wanted. Oops. All right. Stop it. Hex editor, Linux, hex editor. I just need a good hex editor for Linux. Blastful, featured, written, yeah. Oh, interesting. Okay. Sudo blast. Okay. Oh, new. Okay. So we need E0DB /01 count will be, that's gonna, so size will be 4. So that'll be 4. So we've got 4 for the size. We've got 4 for the other size. I'll do 10 and 10 for those two. And then the elf will be elf is 4, right? Yes. Okay, so we've got 28. So that will be 1 up here. 1, 16. We need another 4, 6. That took 2. No. Ah, shit. 1A. Hey, I can not math. 1C. Now it should be 1C. 28. That's what we said. 20. No. I wanted 32. I'm a dumbass. 2. Because we got 4 for the size, 4 for the size, 4 for the elf header, and then 20 more, which would be 20, 32. Then comes the config size, which would be 24, which would be 1A. No. 1, 8. 24. Then we've got provides. Provides is going to be 10. So that's not what I wanted. $20. Damn it. 18. So then we want A, B, C. That's 3, 4, 5, 6, 7, 8, 9. Null. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Null. Okay, so there's our. Then we want 7F, 45, 4C, 46. Oops. 46. Okay. So that should be a proper what did I call it? Something. I called it something. Okay, let's open another terminal. ls/mnt/boot. Yeah, I've got something there. Okay. So nano menu.config sudo cp -mnt/boot/something -mnt/boot/that. Okay. So with any luck, if I pull open box and continue, and I'll put that over there, and continue. Right, I need to run to this root, because it has to read the device. Yes, Ascari, I know how to do math. I just don't know how to do math. Well, that's lovely. Fuck. Stop. Quit you. Alright, what fucked up? This time, let's make sure we build it. Yeah, I'll commit my changes in a second here. Why am I still hitting breakpoint? It's probably that because I didn't pull them out of the kernel. Alright. So, we've gotten basically file reading down. We just got to debug that page fault, which I am willing to bet is reading these bundles, or these modules out of grub. So, let's go ahead and start debugging that and see where we get. So we know that it's somewhere in this. So let's drop a breakpoint here. And let's see where we blow up. It's after this. Da, 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 da. Okay, let's do it before the. Let's do this. Let's do one before the 4. Let's do one before we try and read the bundle. And that should give us an idea of where we are. pointer, cast that to a uint32t. Let's go ahead and just rebuild that. Alright. So we hit a breakpoint. I'm going to move this off screen just so that I can follow what's happening. I'll drop that there. So we came in, hit a breakpoint, then we seg faulted. So it's somewhere between here and here. Let's drop in a break point there and a break point there. So depending on how many breakpoints we hit, if we hit none, then we know that something weird's happening with the for loop, which shouldn't be. Hit one there, yeah. So we hit a breakpoint. So we hit one breakpoint, so the mod struct mod start is not paged in, it looks like. So let's print f struct equals %d %x. The joys of debugging an operating system. Might help if I put in a semicolon. The joys of debugging an operating system. It's run it. Did it blow up? Run it again. Run it. Debug it. Because you can't. You have to compile in all your debugging code. It's one of my favorite things about writing an operating system. Hit a breakpoint. That's why mod struct should be this, which is along, plus that. This plus that. Oops, that should go there. There. No. That's not how that should be. I'm willing to bet we can get away with out-paging this, actually. Which would make life even easier. Did build this, right? I also need to fix that plugin. So we hit a breakpoint. And then we seg faulted. So we hit a breakpoint, hit a breakpoint, hit a breakpoint, then we seg faulted. So we hit, hit. So is it in here? So that's dropping a breakpoint there. Breakpoint there. Breakpoint there. And you know what? Breakpoint there. Oh, I should actually put the return in there. To rat. Okay. And we've done that, so we can quit box. Relaunch box. That is a very good question. Although I don't think I actually use sizes in any... Yeah, I calculate all my sizes except for the count, which should be correct. Thank you. Don't care. Open. Right, it's not mounted right now. I'll mount that and double check, but it definitely should be. So, we hit the first breakpoint, so it's not there. That's not the right one. So we went was it? Okay, so we segfault between here and wherever my last breakpoint was. Let's put a breakpoint here. I have a feeling that mod isn't actually paged in. Just a hunch. And I can get rid of this extra print. Alright. And that's not the window that I wanted. Okay. Let's double check we can isolate that. I really should have put that breakpoint in the last time. But I don't think that malloc is it. I mean, I'm about 90% sure I wrote a proper malloc. And if the module's page aligned, that probably means that it's not paged in. Yes, so it's not paged in. That's not too bad to fix. So that goes away. We page it in. And theoretically, we could say mod equals that. And it should be back paged in. Alright. This better fucking work. Okay. So, not bad. I mean, not great, but it looks like, what did I do wrong? It's probably in what my the actual starting point. Ah. It should be plus equals. And this does mark that unavailable, right? Huh, I don't think that ever marks it as unavailable. Oh wait, yes it does, because when you page it, it marks it unavailable. Never mind. Let's build this and see if that gets us closer to what we want. Oh, right. So really what we want is mod equals the driver mod, which then this is a uint32t, uint32t cast of this, plus, that's equals, plus the uint32t cast of mod. Oh, right. I need another paren. That closes that. That should... Oh. Damn it. Okay. Now, with any luck, we should be well on our way to having something that actually works. Damn it. Damn it, damn it, damn it. I don't think that's what I'm supposed to do. This page doesn't need to be there. I just built it. So let's go over and quit box, run box, continue. Oh, gotta hit continue. That helps. Okay. That's a rather large number. $52FFF. Okay. Let me shut this down for a second. Let me print. Let me do the same thing I do here to see where we are. That's not what I wanted. honestly, I don't need these breakpoints anymore either. When it blows up, it's good enough. If it doesn't blow up, then who cares? Okay, so break that. View the page table. So we've got five, 6, 2,000. Okay. Time to start splitting this into variables. Auto equals that. And we can print f. Damn it. Damn it. Oh, missed a comma. Just got it. That's not what I meant to push. I want to continue. Wait a minute. The module's in. So, map to the physical address 56200, or 2000, okay, is 564,000. So the mod is 562,000. It's now 564,000. Okay. So let's go ahead equals %x mod head magic. Okay. So we're going to kill you. Let you compile. And figure out what the hell I'm doing wrong here. If If it's on nulls, I'm going to be very disappointed. If it isn't on nulls, then that probably means that I wrote it wrong to the file, which I would not put it past myself. Interesting. Very interesting. Looks like my byte order is wrong. Cool. That's easy to fix. So it should be db 0e. Yes. Damn it. Why won't you save? You know what? That's the easier way to do it. Okay, so we've got the file in the right order. Now let's just say, take the magic. I think that's the easiest way to fix it. Don't fix it in the file, fix it in the code. Okay, now let's try box. I don't care about you. It's always ending in this. I mean... It's so... I really wish I knew what it was doing. Not that. It appears that I've made an infinite loop. Alright, so how the fuck did I make an infinite loop? Which I never made it to that? Oh, how I actually read the file? Grub does that for me. I load it as a boot module. So, however Grub does it. If you want to know more, in the Grub 097 manual, module is chapter 13, section 3, part 25. mind you, it doesn't provide much information about how it actually reads in the file. The multi-boot spec, let's see, where does it talk about modules? If I had to guess, it's another endianness problem. Somewhere I'm trying to allocate way too much space. And yeah. Notes on PC. BIOS device mapping, data comparison, IO restriction. Yeah, that doesn't actually give me any useful information about how it's supposed to load either. So, let's make sure we make it into this. Okay, so we do make it into the function, but we don't make it out of malloc, which probably means that mod head count is not what it should be. And I'm just going to get rid of some of these debug prints. I really should implement proper logging, or semi-proper logging. So something along the lines of like a dprintf, and just have that whole function wrapped in a conditional for debug. Not that really matters. Oh. Yeah. Right. So I need to NDNS chain conversion code. So let's go. So I'm gonna go right in some NDNS helpers and stuff. I'm gonna hop off of here. I'll probably be streaming again tomorrow. I'll definitely next time I'm streaming, I'll definitely have the Indian helper and fixed box and a couple other small things that you guys probably won't be interested in seeing. So till then, this has been Garrett.